Okay, in this video I will be doing problem number 12 on the 3.2 homework. And so let's go ahead and get started. In this problem we're going to be using the empirical rule, but we're also going to check it by actually counting what percent of the data falls within the percentages that the rule gives us. So let's go ahead and get started. So here we have the accompanying data represent the weights in grams of a random sample of 48 M&M plain candies. So they've been weighed in grams. Complete parts A through F. All right, so it says determine the sample standard deviation weight. So let's go ahead and do that. And so there's our data, and let's go ahead and go to StatCrunch. So you can see the data has been imported, and so we're going to go to Stat, Summary Stats, Columns. We need to pick our column, and let's see, we're finding the standard deviation of a sample, and so we'll use this here. Now if we were looking for the standard deviation of a population, we would use unadjusted standard deviation. So this is for a sample. That's what we're usually looking for a standard deviation for. So let's select that and compute. And so I don't know if you can read it. It's 0.0352. So rounding to 3 decimal places, it's 0.035. And so let's go ahead and put that in. 0.035. So we're set on A. So on the basis of the accompanying histogram, comment on the appropriateness of using the empirical rule to make any general statements about the weights of M&Ms. So we can use the empirical rule if it has a bell shape, and you can see that it does here. And so the histogram is approximately bell-shaped, so the empirical rule can be used. There we go. All right. Use the empirical rule to determine the percentage of M&Ms with weights between 805 thousandths and 945 thousandths of a gram. And they're telling us the mean here. Just real quick, we might as well go ahead and find it, since it's just a good reminder of how to do that. It's just like what we did here, except for we're going to go back in, and instead of choosing standard deviation, we're going to choose the mean and compute, and you can see it is 0.875, and so they gave it to us, but we could find it quite easily. All right, so let's go back here, and so now I'm going to go ahead and let's see, we want to know what percentage, based on the empirical rule, of the M&Ms have weights between 805 thousandths and 945 thousandths of a gram. So 0.805 and 0.945, and 875 or 875 hundredths is our mean, sample mean. All right, so I'm going to switch to my camera, and let's see, what can I do here? I think that'll be okay. So remember the standard deviation, actually I don't remember, I didn't write that down. Let's see what that is. We said it was 0.035. So that's our standard deviation, or little f. So 0.035. So we're going to add 0.035 to 875. So 0.875 plus 0.035, and that's 0.910, and we'll add 0.035 0.035 again. And we'll get 0.945. And remember, that was one of our numbers, and so that's 2 standard deviations above the mean. So basically, this is our mean. We added 1 standard deviation. We got this number, 91 hundredths basically. And then here we added another 35 thousandths. Again, that's our standard deviation. And we got 945 thousandths, which was the number that we were looking for, one of them anyway. So we're also going to subtract 0.035 from 0.875. So 0.875 minus 0.035. And here we get 0.84. If you want, I'm just putting them all to 3 decimal places. And then let's subtract one more time. Minus 0.035. And you get 0.805. And that was our other number. And so you can see it had asked what percentage of the data is between these two numbers. Well, that's within 2 standard deviations, and we know that's 95% of the data according to the empirical rule. So let's go ahead and put that in. 95, and so that's good. Now it says determine the actual percentage of M&Ms that weigh between 805 thousandths and 945 thousandths grams. Inclusive means if either of those values are part of the data, that we would include them. So let's go back to our data, and you know what, I didn't write that down. Let me write those numbers down. Well, actually, it's the same numbers as before, so let's go to our spreadsheet. So what we're going to want to do is sort this data so it's from lowest to highest, and so we can go to Data, Sort, and it's the first column, VAR1, and we're going to sort by that column. It's ascending, so from lowest to highest. And so there we go. And so you can see this is 810 thousandths, and that's bigger than 805 thousandths. And so 79 hundredths is the only one that doesn't get included there. And if we go to the bottom, let's see, it's got to be between, or it's got to be lower or equal to 945. So this would be 0.940, so that's lower, but 0.950 is bigger, and so it's these numbers here. Let me go ahead and just go up to the top. And let me go down just, so it's basically all of those numbers that fall between 805 thousandths and 945 thousandths. So you'll notice that was just all but 2 of the values. So remember, there was 48 total M&Ms, and so 46, so let me go back to my paper, 46 out of the 48 are between those 2 values. And so let's go ahead and do the division. 46 divide 48, and we get 0.958. I think we had to round to 1 decimal place. Let me check here. Yeah, round to 1 decimal place, so it'll be 0.958. Oh shoot, it's a percent. 95.8%. Whoops, I didn't change it. 95.8. There we go. So use the empirical rule to determine the percentage of M&Ms with weights more than 910 grams. Okay, so let's go back to our picture. more than 910, that would be here. Now remember, in here, within one standard deviation, we have 68% of the data. What that means is outside of there, you'll find the difference between that and 100. So 100 minus 68 is 34. So half of that's here and half of that's here. Half of 34 is 17. Wait, I'm sorry, I said that wrong. It's not 34, it's 32. So so we have 68% of the data in here. And remember, this is symmetric, so outside of that, we have 32% of the data. Half of it's here and half of it's here. Well, half of 32 is 16. And so we should say 16%. So let's go back. 16. And let's check our answer. And so finally, I think this is the last one. Determine the actual percentage of M&Ms that weigh more than 910 thousandths of a gram. So let's go back to our spreadsheet. And so here is 9, 10, and so it's these here. There's 1, 2, 3, 4, 5, 6. So 6 out of the 48 are greater than 910 thousandths, or 91 hundredths. If we divide 6 by 48, we get 12.5. Well, it's 0.125, so it's going to be 12.5%. All right, so that should be it. Let's go ahead and plug that in. 12.5. So you'll notice with this one up here, we were pretty close. With this one here, we're a little bit small, but still not outside of reason when you consider the variability when you look at samples. So let's go ahead and check our answer. And I think that's it for this video.